At the end of this chapter, let's work on some practices over reactions of alkenes. The first thing we work on is this compound. We are going to add water through two different methods of hydroboration, oxidation, and also oxymercuration, demercuration. You need to know the reagents for each one and the name of each one. The mechanism, not the detailed step by step. I mean, what type of mechanism is it? It is a syn addition and non-Markovnikov, but oxymercuration demercuration is an anti-addition and it's a Markovnikov reaction. So by that we don't need to apply the step-by-step mechanism. Non-Markovnikov means H is going to be added to hydrogen poor carbon. So hydrogen will be added to this carbon. Hydrogen poor, right? This carbon has no hydrogens, but this carbon has one hydrogen, so OH will be added. Also, it is a syn addition, so means that both OH and H are added from the same site, so H and ethyl group are going to be on the other side. So this is the meaning of syn and non-Markovnikov. The other one is just the opposite, anti and Markovnikov. So Markovnikov means a hydrogen will be added to hydrogen-rich carbon, so we need one more hydrogen here, and we have a CH2CH3, so OH will be added to this carbon. It's anti-addition, so if OH is on wedge, the hydrogen you're adding is on dash. Okay? Now, another type of question that we have in this part is to go from the product to the reagent, to the reactant. So let's see how it works. For example, you have this product, and this is the methyl group here. So we want to find out what alkene we need to prepare this alcohol by oxymercuration. So we need to know the facts about oxymercuration. First of all, these are the reagents. If I'm making any mistake in any of the reagents, please check with the literature. So oxymercuration means it was Markov-Nikov. Obviously, we don't have the wedge and dash here, so we already know this is anti, but what is more important here is Markov-Nikov. So here we have the OH, and if we consider this side as double bond, because we have OH here, double bond can be here or it can be here, correct? Now let's check which one is the correct answer. If we consider this alkene, this is hydrogen poor region, carbon, right? So Markov-Nikov means hydrogen will be added to hydrogen rich. So it would be hydrogen here because it already has one hydrogen, and OH will be added to this. Is this the alcohol we want? No. So we need to choose this one. That means H and OH will be added to these two carbons. So this is your alkene. So in order to go from product to the reactant, we have to determine the location of the reaction first. It's either here or here, and I just explained why we cannot have the other compound. The other one with the same exact reagents Again, we need to determine the location of reaction. It's either the double bond is here or here, right? Let's put it here. If we have double bond here, in the reagent, in the reactant, we don't have OH, right? So let's see. If we have this compound, this is the hydrogen-rich carbon. So hydrogen will be added here, and OH will be added here. And we end up having that compound. But if we have this here we have 1, 2, 3, 4. This is hydrogen poor, and this is hydrogen rich. So hydrogen will be added here, and OH will be added here. But this is not the compound we get. So you need to pay attention to the location of double bond based on the number of hydrogens. Another type of questions which you start having is how to synthesize a compound, which is very important. Synthesize means how to put the compound together, how to make it. The first one is how to go from this compound to this compound. So, you see, we are going from an alcohol to a dihalide. We cannot add or substitute any OH with bromine. At this point, you haven't learned any reactions like this. Means that first you need to prepare this compound for the addition of 2 bromine. Means you need to have an alkene, right? If you have an alkene like this, then you can add bromine to it, right? How do you change an alcohol to an alkene? By using POCl3 and pyridine. Go back to preparation of alkenes from alcohols and review it one more time. Okay. The next one is how to go from this compound to this compound. So first analyze the product. In the product, seems like this is a carbon, right? Seems like there was, let's put it here. There was an alkene here, so we added what? H2O and a chlorine, right? And it was Markovnikov, means halogen is added to hydrogen-rich carbon, which matches it. But how to change this to this? We can use an elimination reaction. Don't forget we had a big bulky base, strong, to change. So we remove an HB, or elimination reaction, from previous chapter. We shouldn't forget the previous chapters, right? The other one, going from this alcohol, a tertiary alcohol, to a secondary alcohol. So, seems like we need to add, seems like there is a double bond here to add OH and H. This is hydrogen poor, and this is hydrogen rich. But OH has been added to hydrogen rich, so we need to apply a hydroboration oxidation here. But how to change this to this? We can easily use sulfuric acid and acid. So that's how you need to analyze the products to get to the reactants for the synthesis questions. You always have to dissect. You have to just focus on what happened on the functional group. And imagine a functional group in the position. So, and it's just that the skills are obtained just by practicing, not by just going over one or two. So on the last page of this study guide, I just work on a few of the reactions. You have a propene, which is this compound, and you have a cyclohexene. Cyclohexene, which is this compound. So if you add HBr, you will add hydrogen. This is Markovnikov. So you will add bromine to this side. To this compound, doesn't matter because Markovnikov doesn't apply here because each of these has a hydrogen. So with a bromine here, hydrogen here, or vice versa, as if like you flip the molecule. Cl2, CH2, Cl2. It's the Markovnikov doesn't matter here, but it's an anti-addition, means we need to show the trans product. Okay. Oh, sorry, this is Cl. Sorry, my bad. To the other one also, you show the trans product. The next one is NBS, H2O, and DMSO. So let's see what you have here. NBS bromine is a good source of bromine. So you are adding bromine and water. It's Markovnikov and anti. These are the facts you need to know about every reaction. So Markovnikov means bromine will be added to hydrogen-rich carbon. And anti means they are on the opposite positions. OH will be added to this. And in this case, doesn't matter because there is no difference between the hydrogens. The next one is, I told you I'm going just to go over some of them, but I'm going to go over everyone. At this point, don't worry about we can work on it. We can work on it. It's just the addition of ether. So the same, Markovnikov and anti. Markovnikov and anti. So chlorine will be added here, and instead of OH we have OCH3. And again here, doesn't matter which one is receiving chlorine. The next one is addition of water as oxymercuration. So this is anti and Markovnikov. You see, I am considering all of these facts for every single reaction. So we are adding water, oxymercuration, demercuration, anti, and Markovnikov. Markovnikov means hydrogen will be added to hydrogen-rich carbon. So this is a hydrogen, and this is a OH. Again, in this case, doesn't matter which one gets hydrogen, which one gets OH. And finally, the opposite way, we have BH3 in THF, and we oxidize with hydrogen peroxide in base. So this is syn and non-Markovnikov, just the opposite of the previous one, which was anti and Markovnikov. So don't forget, these two work the opposite. So we have hydrogen here, OH here. Oops, sorry. This is syn. So you have a cis. And here again, you have it cis. Please don't forget to work on plenty of practices and examples. The more, the merrier. And good luck.